Hello and welcome to a weather topic video. It's been a while since I've done one of these. I know I've been busy with just pure tornado outbreak videos. Today I'll be trying to explain to everyone here why tornadoes are so dangerous. A mildly detailed look into some of the key reasons that I was able to discover. So we have four main reasons here. The wind speed, of course, which is a main contributor of tornado strength, go figure, and debris. The oversaturation of tornado warnings, the unpredictability and uncertainty that tornadoes cause, and last but not least, the tornado or the updraft of the storm. We'll be going over wind speed first. As we can tell, this picture here, claimed by Alamy, because this is my Joplin damage photo, Alamy says, not anybody else's, can do some extreme damage. This car is wrapped around a tree, and this tree has also been debarked. And this tree over here in the bottom left is also debarked. So again, wind speed, this is the main contributor to strength and debris, like I just said. EF5s can toss manhole covers. For those of you in the EU, I don't know if you know what I'm talking about. Manhole covers are like solid metal, like at least 50 pounds at bare minimum. And EF5s have been noted to flip over many thousands of kilograms of material. I think one EF5 in particular that I covered tossed like a almost 100,000 kilogram oil rig and rolled it 3 times. That is insane. Even EF0s can throw tree branches. You're not even safe from an EF0. Tree branches, well, you're like, oh yeah, it's a branch. No, those things can cause some pretty severe damage to your face or just your body in general. Something that I just remembered here, tornadoes can hurl 2x4s into concrete, impale concrete. The 1974 Tanner, Alabama EF5 dug a bathtub 2 feet into the ground. The updraft, this is the reason 2, and this is the part circled in pink, specifically obviously rotating updraft because that's what's needed for a tornado. First of all, the updraft is the tornado. This will be rising, of course. It is an updraft after all. Be lifting anything that it possibly can. Now, granted, there is a caveat here. A rotating updraft does not mean a tornado. That is one of the biggest parts to why there is uncertainty and unpredictability. 3 things here, all rely around the fact that they do not produce a tornado necessarily. A supercell or a bow echo kinks do not produce tornadoes all the time. A rotating updraft or simply rotation aloft being detected by Doppler radar does not mean a tornado, and perfect conditions outside of the cell does not equal a tornado. And you're thinking, Hex, you just said everything that can cause a tornado doesn't produce a tornado. So why do we have tornadoes? Because of Mother Nature, that's why. The unpredictability of tornadoes causes oversaturation of tornado warnings. 3 out of every 4, or 75% of all tornado warnings in the US are false alarms. This is because Doppler scans high up into the storm and sees rotation. Therefore, the NWS has to assume that there's a tornado, sending out a warning, but the cell never bears fruit, and this fruit being a tornado. This is one of the biggest problems with tornado detection is Doppler radar, but that's just how Doppler radar works. Doppler radar is, well, radar, so radio waves, are being sent out from the radar and are bounced back. That's why things on radar are called bow echoes or hook echoes, because that is the echo from the radio waves bouncing back to the radar and being detected by it. So the connections to all this, except for wind speed, of course, is that the updraft is all up in the storm, of course, as it should be, and is rotating. Doppler detects only the higher level rotation because it needs a clear line of sight to shoot out those radio waves, see that storm relative motion, and then uh, it comes back. That's why it's, again, hook echo and bow echo, because it's seeing what is being reflected back. If a Doppler, I don't know if any of y'all have seen the Doppler soccer ball, as they call it, on a tower. But if you took that tower away and it was just on the ground, it would be detecting trees and cars and buildings, and you're just going to get a constant blip of hail and heavy rain. It's like, no, that's the NWS building. Last time I checked, that's not rain and hail. So you have to put it on a tower so it can get above all these things. And that's why it sees the high level rotation up in the storm. This leads to an oversaturation of tornado warnings, and it's not the NWS's fault and it's not Doppler radar's fault. It's just simply because of how unpredictable tornadoes are with just Doppler detection, not rotation. Now, storm spotters and storm tracers, as well as law enforcement, help out immensely with this. So obviously, since I'm talking about them, this is where spotters come in to help. Spotters are an extremely important factor with tornadoes when the NWS is trying to detect them. Because it's not just rotation detected aloft with Doppler, it's this tornado has been spotted by multiple storm chasers and storm spotters and law enforcement. So yes, while tornadoes are just wind, it is a lot to deal with because simply there's too many caveats to tornado genesis. So I hope that explains why tornadoes are so dangerous. I know that a relatively simple question can turn into a very deep dive, but that's sometimes